Dear students, now we are going to see the topic DC characteristics of operational amplifier under the subject linear integrated circuits, and the subject code is EC3451. On the completion of this DC characteristics of op-amp, the students will be able to summarize the non-ideal DC characteristics of operational amplifier. The current is taken from the source into the op-amp input respond differently to current and voltage due to mismatch in transistor. A real operational amplifier also shifts its operation with temperature. These non-ideal DC characteristics that add error component to the DC output voltage, that are input bias current IB, input offset current IOS, input offset voltage VIOS, and thermal drift. Input bias current. If the input is 0, output should be 0. In practical, it produced a current in nanoamps without giving input. This is known as bias current. The average value of two current flowing into the op-amp input terminal is called the input bias current IB. The two input currents are identical due to mismatch in transistor. Let IB plus be the current flowing into the non-inverting terminal. IB minus be the current into the other terminal. Then the input bias current IB is given by IB plus IB minus by 2. The current IB plus flowing through the compensating resistor or compensation. Then by applying Kirchhoff's voltage law, we get minus V1 plus 0 plus V2 minus V0 equal to 0. So V0 equal to V2 minus V1. By selecting at the proper value of our compensation, V2 can be cancelled with V1 and V0 equal to 0. The value of compensation resistance is derived as V1 equal to IB plus into our compensation. IB plus equal to V1 divided by our compensation. The node A is at voltage minus V1 because the voltage at non-inverting input terminal is minus V1. With Vi is equal to 0, we get I1 equal to V1 by R1, I2 equal to V2 by RF. For compensation, V0 should be equal to 0. So V0 equal to 0 for Vi is equal to 0. From equation 3, V2 equal to V1. So that I2 is equal to V1 by RF. Apply KCL at node A gives IB minus equal to I1 plus I2 equal to V1 by RF plus V1 by R1 equal to V1 into R1 plus RF divided by R1 RF. Assuming IB minus equal to IB plus and using equation 2 and 5, we get V1 into R1 plus RF divided by R1 RF equal to V1 by R compensation. So R compensation is the parallel combination of R1 and R2, RF. The components, that is to compensate for bias current, the compensating resistor or compensation should be equal to the parallel combination of resistor R1 and RF. Input offset current, the bias current compensation will work if both bias current IB plus and IB minus are equal. Since the input transistor cannot be made identical, there will always be some small difference between IB plus and IB minus. This difference is called offset current IOS. IOS is equal to IB plus minus IB minus. Offset current IOS for BJT op-amp is 20 nanoamps, for FET op-amp is 10 picoamps. Even with bias current compensation, offset current will produce an output voltage when Vi is equal to 0. V1 equal to IB plus into our compensation and I1 equal to V1 by RF. Applying KCL at node A gives I2 equal to IB minus I1 equal to IB minus IB plus or compensation by R1. The output voltage V0 is equal to RF into IOS and V0 is equal to I2 into RF minus V1. V0 is also be written as I2 into RF minus IB plus into our compensation. Input offset voltage. It is found that the output voltage may still not be zero with zero input voltage. This is due to the unavoidable imbalances inside the operational amplifier. One may have to apply a small voltage at the input terminal to make the output to zero. This voltage is called input offset voltage VOS. This is the voltage required to be applied at the input for making the output voltage zero. Total output offset voltage at 10 kilo ohm potentiometer is placed across offset null pins 1 and 5 of operational amplifier. The wipe connected to the negative supply chain or pin number 4. The position of wipe is adjusted to nullify the offset voltage. When the given op-amp does not have these offset null pin, external balancing techniques are used. Without compensation, the total output voltage VOT equal to 1 plus RF by R1 into VOS plus RF into IB. With R compensation, the total offset current is voltage is given by VOT equal to 1 plus RF by R1 VOS plus RF into IOS. Thermal drift. The bias current, offset current and offset voltage change with temperature. A circuit carefully nulled at 25 degrees centigrade may not remain. So when the temperature rises to 35 degrees centigrade, this is called a drift. Offset current drift is expressed in nanoamps per degree centigrade. This indicates the change in offset for each degree Celsius change in temperature. The possible questions are: change in input bias current does not affect the input offset voltage, output offset voltage, input offset current and output offset current. The answer is input offset current. The maximum amount by which the two input bias current may be differ is given as input offset current. Thank you for watching.